This tutorial is about force and acceleration. The most commonly used equation for this is F equals ma, or as you'll see on your formula sheet, the resultant force, or F resultant, equals ma. A quick reminder about force. A force is a push or a pull or a twist. It's measured in newtons, capital N being the unit, and the combined effect on a number of forces acting on an object is called the resultant force. Here's an example of an object which has 3 forces acting on it. The combined effect is 10 newtons downwards. So what we say is the resultant force in this example is 10 newtons downwards. There are unbalanced forces acting on the object. Now, with force and acceleration, it's all to do with these unbalanced forces, and we say that when an unbalanced force acts on an object, it will accelerate in the direction of that unbalanced force. The acceleration will be inversely proportional to the mass. What does that mean? Well, it means that the bigger the mass, the smaller the acceleration. It's far more difficult to get a big object moving than a small object, so that makes sense. There's the equation that we'll be using in this tutorial, but the one on your formula sheet, remember, has F res as the formula. And remember, we can change this into a magic triangle, F equals ma, the ma at the bottom. And the way we use this is cover the F to get the ma, so that means m times a. Cover the m, and you'll find m equals F over a, or F divided by a. Cover the a, and you get a equals F divided by m. Now you might have to use all forms of that equation, in particular this last one. Acceleration is force divided by mass. Here's some examples. Calculate the force required to cause a 20 kilogram object to accelerate at 5 meters per second squared. So we're looking for F, so write down the equation, F equals ma. Substitute the values, the mass is 20 and the acceleration is 5, and write down the answer with the correct unit. In this case it's 100 newtons. A second problem. A force of 300 newtons acts on an object of mass 50 kilograms. Calculate the acceleration of the object. In this problem we'll assume that the 300 newtons is the resultant or unbalanced force. So in our magic triangle we're looking for a, so write down the remaining equation, a equals F divided by m. Substitute the values, 300 is the force, 50 is the mass, 300 divided by 50 is 6, and its acceleration, so the unit is meters per second squared. If you were given a diagram as a problem and you have to calculate the acceleration, first of all, work out that unbalanced force. It's going to be 20 plus 10 on the one side, subtract 13 on the other, so you get 17 newtons, and that's to the right. So the problem actually simplifies to this. Now work out the acceleration. So again, a is F over m. Substitute the force, but remember it's the resultant force, so 17 divided by the mass, which is 2, and that is 8.5. So a, acceleration, 8.5 meters per second squared. And here, seeing that you know the direction, add it, so to the right. How about a problem where you're not given one of the forces? So we know there are 2 forces acting on this. There's the 24 newtons applied force to the right, and there's friction slowing it down to the left. The question is to calculate the force of friction if this object accelerates at 3 meters per second squared. First, find the unbalanced force using the F equals ma equation. So F equals ma, we know the mass is 5, we know the acceleration is 3. So 3 and 5 times 3 is 15, and that's newtons. Then we'll find the force of friction. Well, we've got 24 and we've got to subtract friction, and we know we're going to get an answer of 15. So you should be able to rearrange that and find out that friction is 9. That comes from 24 take away 15. Now if we looked at the problem with that friction involved, you would see the 9 to the left, the 24 to the right makes a resultant of 15, and 15 divided by 5 is 3 meters per second squared, so that works out well. Just a quick note on weight. Weight is a special kind of force. It's the force with which a body is attracted to the Earth or any other celestial body, like, say, the Moon. It's equal to the object's mass multiplied by the acceleration due to gravity of that celestial body. So the equation will be F equals ma, and in this case weight will be mass times gravity, or acceleration due to gravity. On the Earth that'll be approximately 10, so weight will be mass multiplied by 10. Mass is the same no matter where the object is, whether it's on the Moon or on Earth. Weight depends on the force of gravity of the celestial body. So let's look at an example between the Earth and the Moon. On Earth, the acceleration due to gravity is approximately 10, and on the Moon it's approximately 1.6. So if we had to work out the weight of a 20 kilogram object, well, it's 20 kilograms on the Earth as well as on the Moon. That doesn't change. But the weight on Earth is 20 times 10, because that's the acceleration due to gravity, so it's 200 newtons, while on the Moon it'll be 20 times 1.6, so it's only 32 newtons on the Moon.